Hello students, welcome to the lecture on computing platform, and after the lecture we will be able to learn the following objectives. Understand the concept of personal computers, describe the mainframe computers, explain the features of mainframe RAS, describe the key elements of RAS, explain the mainframe hardware. Let's start with a brief introduction to computing platform. A computing platform is some sort of hardware architecture and software framework, including application frameworks that allow software to run. Typical platforms include a computer's architecture, operating system, programming languages, and related user interface. A platform is a crucial element in software development. A platform might simply be defined as a place to launch software. It is an agreement that the platform provider gave to the software developer that logic code will interpret consistently as long as the platform is running on top of other platforms. Logic code includes bytecode, source code, and machine code. It actually means execution of the program is not restricted by the type of operating system provided.
Increasingly, applications are constrained by the availability of compute resources to deliver results in a timely and efficient manner. In response, businesses are building computing clusters and connecting them into grids and even HPC clouds. Users want to accelerate applications to speed time to results. IT needs to make the best use of heterogeneous IT resources to maximize utilization and throughput. With IBM Platform Computing, all of this is easier and faster than ever before. Clusters should be able to support managing lots of job submissions for many different types of applications and many groups of users. Within the data center, there can be all sorts of different resource types: virtual, bare metal, different operating systems, networking, storage, to support the diverse workload requirements. But how do you connect these workloads to the resources in a highly secure, scalable, and reliable fashion? IBM Platform Computing provides the management software and middleware to optimize high-performance applications on scale-out infrastructure. How? By delivering 6 key capabilities with a comprehensive, scalable, and robust portfolio of workload and resource management software. IBM Platform Computing uses these capabilities to optimize a typical customer process. End users submit jobs via our easy-to-use web portal. The system aggregates all the jobs from users and applications, and according to an intelligent set of highly flexible and robust business policies, determines the appropriate resources for the workload, a process called workload management. Integrated cluster management makes it easy to deploy, manage, and dynamically update the cluster resources as required. Without workload management, jobs, each requiring different resources potentially, are executed as submitted without concerns about optimizing the overall utilization, throughput, or performance. In contrast, IBM Platform Computing can dynamically place jobs on resources and continuously and dynamically optimize both job scheduling and resource management, and hide all this complexity from end users while simplifying administration. Administrators can monitor the health of the system and use advanced analytics to identify opportunities to remove bottlenecks, optimize license usage, do capacity planning, and improve the performance of the overall system. And IBM Platform Computing provides an integrated solution, one that's easier for IT to deploy, administer, and support. Combined with its industry-leading scalability and performance, IBM Platform Computing delivers comprehensive workload and resource management for today's mission-critical IT requirements. The net result for IT is better performance, lower costs, and happier end users.
Now, we will talk about personal computers. Personal computers are computers that are meant to be used by individuals in homes or offices. Personal computers were first introduced on the market in the late 1970s. Their capabilities and speed left much to be desired in comparison with modern PCs. But because of the advancement they represented, their popularity grew quickly and PCs began to be developed for everyday household use. Computer games and programs were developed which could be used on a household computer. All PCs have several basic components that allow them to function and be used. The microprocessor controls everything the computer does, and every process has to go through it first. Computers also have memory, both long-term and temporary, as well as data storage. ROM, ROM, contains the basic software that allows the computer to boot up and generally does not change. RAM, RAM, is used to store information that the computer is currently working with, such as open programs. Another important part that is common to all personal computers is the power supply, which regulates the amount of electricity that the PC is using at a given time. Most computers also have sound cards and graphics cards as well, which are small circuit boards that connect to the motherboard to process audio and video data, respectively. Some modern PCs also include a CD-ROM or DVD-ROM drive.
The outside of your computer, relatively straightforward, not a lot of different pieces because almost everything is contained in the primary system unit that you have. But of course, on your system, you've got to have some way to see the information that the computer's telling you about. This output screen, something that we call a monitor. And the monitor is probably LCD based if it's a newer computer, but it may be some of the older cathode ray tubes or CRT monitors, which are really big and glass and bulky. And you don't see a lot of them anymore. It's hard to buy them anymore, but almost every single computer is going to have some type of monitor on it so that you can get output of your system and see what's there. You've probably also got a keyboard and a mouse on your computer. These days, those can be usually two separate components, or you have a separate keyboard and a separate mouse. If you're working in a data center, you may find that the mouse is actually part of the keyboard, or if you're on a laptop, for instance, the mouse is integrated into the keyboard piece. And so sometimes those are two separate pieces, two separate physical components separated out. Sometimes those two components are encapsulated or brought together on a single platform. They're still considered a separate keyboard and separate mouse. They just happen to be in the same unit itself. And finally, we have the computer itself. Some people will refer to this as your CPU. Technically, of course, the CPU is a chip that is inside of your computer case, but we often refer to that of the CPU that you happen to be connected to. You may also find these days, especially things like the Apple iMacs, for instance, the monitor and the computer are all in one. You just have a monitor and a keyboard and mouse. There's no separate computer anymore. So sometimes everything that you would normally find inside of your computer case just now is starting to become part of the monitor itself. We still refer to that as the computer components, though, and we'll step through what you can expect to find inside of that system, whether it's one that's integrated together with a monitor or whether it's the more traditional separate computer that's out separately away from all of these different pieces. But all the real action is inside of your computer. All the really good stuff is happening inside of the system. And normally we don't get to see that. There's a case, there are screws you must unscrew to get the top off of that or to get the side off of your system. Before you go into your computer, the one rule of thumb that you always must follow whenever you are taking a cover off of a computer is to unplug it from its power source. Make sure it does not have a way to power up once you unplug that cover, once the inside components are accessible to you. That way you can be sure that you are never going to be in a situation where there is an accidental case of electricity flowing into you. We don't want that to happen. That can be absolutely a fatal type of situation. So it's just something to keep in mind. Very simple. You unplug and you're safe. That type of safety tip is always good. People send me messages all the time at ProfessorMesser.com and say, I never unplug my system. I just take the cover off and I'm perfectly fine. Well, that's certainly the case. As long as you don't touch the wrong thing, you'll be fine. The problem, of course, is when you accidentally do touch the wrong thing. There are some very, very, very powerful electrical pieces inside. So if you're ever going to do this, just make sure you unplug from a power source. So what I did was take a system that I had so that I could show you what's inside of mine. Now, my system itself is one that has, it's designed to go as a server. It's very flat. So when I take the cover off, I'm able to see almost everything inside the system just by taking its top cover off. So it's a really good one to use for this example. Your system, when you take it apart, may not be designed this way. The different components may be on top of each other, may be hard to see underneath different pieces. But everything in your system probably does have exactly the same type of components, even though it's designed just a little bit differently on the inside. Let's step through what a few of these might be. Now, the one that we just talked about that's very important to unplug from is the power supply. And if we were on our system right here, on the back of it, it's kind of hard to see right down here at the bottom is where the power plugs right into this power supply. So before I did anything with this system, I unplugged it from the power supply, and now I can feel comfortable about going in here. Notice the power supply also has this big metal cover over it. There are some capacitors in there that will store power. So you want to be very careful that you're never taking this metal cover off of your power supply because there are some very high voltages in there. You will find equipment, usually it's not a personal computer, but other types of computing systems inside of data centers and other components, you'll take the cover off and the power supply will not have a metal cover on it. Be very careful about working around those types of pieces of equipment and those environments. You don't want to be in a situation.
Here, we will get to know about workstations. A workstation is a computer designed for professional use by a single user. It usually has more capacity than a personal computer, but is not as high-powered as a mainframe computer that is designed to support very complex calculations and multiple users. Workstations provide people with computing power for a variety of tasks that may require high power, such as creating three-dimensional digital models. The specifications of a workstation shift as computing standards change. What was once viewed as a high-powered, top-of-the-line workstation might today be less powerful than a calculator used by a high school student. Improving technology has allowed workstations to become smaller. A high-powered laptop can qualify as a workstation, and desktop workstations may have relatively small tower units. Desktops usually have large screens and sometimes multiple screens to support tasks that require a lot of screen space. The resolution of the screen is also typically high quality for clarity and crispness. Now we will discuss about mid-range computers. A mid-range computer is a loosely defined term for a computer system that is more powerful than a general-purpose personal computer, but less powerful than a full-size mainframe computer. In most instances, a mid-range computer is employed as a network server when there are a small to medium number of client systems. The computers generally have multiple processors, a large amount of random access memory, RAM, and large hard drives. They usually contain hardware that allows for advanced networking and ports for connecting to more business-oriented peripherals such as large-scale data storage devices. The use of a mid-range computer is not limited to businesses. However, as some people build or purchase mid-range systems when high-end personal computers are insufficient, as could be complex real-time image processing or computer gaming. The Central Processing Unit, CPU, on a mid-range computer is frequently a multi-core design, meaning there are several physical processing chips on the motherboard working in tandem. This allows a mid-range system that is being used as a network server to run several independent processes concurrently, increasing the speed and efficiency of the computer. The large amount of RAM and hard drive space, sometimes containing more than a terabyte of storage. Let's learn about mainframe computers. Mainframes are very large computers that are built to be able to perform complex and critical applications. They are usually very large in both physical size and computational ability, and they can be some of the largest machines on the planet. However, given the continued drive toward greater computational muscle in a smaller physical package, many mainframes are not too much larger than a desktop computer these days. These large computers are designed to keep running with as little interruption as possible. They contain large numbers of self-maintenance features, including built-in security features and backup power supplies. Since mainframes are usually the most important computers in a company's computational arsenal, they are routinely protected by multiple layers of security and power backup, both internal and external. Larger mainframes are not always user-friendly unless the user is the system administrator. These computers are designed to stay running, not to be available for users' whims. However, the lack of approachability is more than made up for by their increased ability to keep running in situations that would likely disable other systems. Mainframe RAS features: reliability, availability, and serviceability. RAS is a set of related attributes that must be considered when designing, manufacturing, purchasing, or using a computer product or component. The term was first used by IBM to define specifications for their mainframes and originally applied only to hardware. Today, RAS is relevant to software as well and can be applied to networks, application programs, operating systems, OSs, personal computers, PCs, servers, and supercomputers. The term reliability refers to the ability of a computer-related hardware or software component to consistently perform according to its specifications. In theory, a reliable product is totally free of technical errors. In practice, vendors commonly express product reliability as a percentage. The Institute of Electrical and Electronics Engineers, IEEE, sponsors an organization devoted to reliability in engineering known as the IEEE Reliability Society, IEEE-RS. Availability is the ratio of time a system or component is functional to the total time it is required or expected to function. This can be expressed as a direct proportion, for example, 9/10, or 0.9, or as a percentage, for example, 90%. It can also be expressed in terms of average downtime per week, month, or year as total downtime for a given week, month, or year. Serviceability is an expression of the ease with which a component, device, or system can be maintained and repaired. Early detection of potential problems is critical in this respect. Some systems have the ability to correct problems automatically before serious trouble occurs. Examples include built-in features of OSs such as Microsoft Windows XP and AutoProtect-enabled antivirus software and spyware detection and removal programs. Key elements of RAS. Some of the key elements of RAS are over-engineering. This is designing system to specifications better than minimum requirements. Duplication. This is extensive use of redundant systems and components. Recoverability. This is the use of fault-tolerant engineering methods. Automatic updating, which keeps OSs and applications current without user intervention. Data backup. This prevents catastrophic loss of critical information. Data archiving. This keeps extensive records of data in case of audits or other recovery needs. Power on replacement. It is the ability to hot swap components or peripherals. The use of virtual machines. It minimizes the impact of OS or software faults. Use of surge suppressors. It minimizes risk of component damage resulting from power line anomalies. Continuous power. This is the use of an uninterruptible power supply. Keeps systems operational while switching from commercial power to backup or auxiliary power. Backup power sources. This includes batteries and generators to keep systems operational during extended interruptions in commercial power. Now, let us get to know how mainframe computers are not good at everything. Mainframes are not good at number crunching or do not do scientific calculations. A mainframe is not a supercomputer. Mainframe computers are not meant for speed. They are not fast. Rather, they can process humongous data reliably. Mainframe computers do not have a beautiful user interface like the PC at the home. One would not find desktop wallpaper or icons on a mainframe computer.
Mainframe hardware. A mainframe computer has processing units, PUs, memory, I/O channels, control units, and peripheral devices. A processing unit, PU, is the brain of the mainframe computer that executes instructions. A mainframe computer has many processors. The total of all processor units, PUs, are inside a cage, frame, called the Central Processing Complex, CPC. There are specialized PUs capable of performing specific tasks. The main processors are called the Central Processor, CPs. There are PUs for encryption and decryption, CPACF, Linux workloads, IFL, the coordination of the system efforts, ICF, those that assist the CP for any workload on the I/O subsystem, SAP, spare, that come in handy when a CP fails, others for executing Java code and providing accelerated DB2 performance. Mainframe peripherals. In the early days, one operated a mainframe computer by a terminal. A terminal had a display and a keyboard. A very popular terminal manufactured by IBM in the 70s was the 3278 terminal. Terminals were connected to a mainframe computer remotely over a network. They used the IBM 3270 protocol for communication. IBM no longer manufactures terminals. Instead, one uses PC running software that mimics the terminal. Storage devices such as magnetic disk drives are used as secondary memory. IBM uses the term DASD, Direct Access Storage Device, pronounced as DASD, for hard disks. Disk drives support random access to data. IBM 3380 and 3390 DASD models are widely in use. Tape drives are also used for storage. A tape drive allows sequential access of data. Very large files can be stored on tape drives. Mainframe computer industry and the people involved. To oversee the running of a mainframe computer, one needs to hire professionals called system operators, SysOps, SYSOPS. Mainframe SysOps have good knowledge of the mainframe architecture and the operating system. The operating system on the Z10 mainframe computer is the ZOS. A mainframe operator starts initial program load, IPL, or shuts down the mainframe and various regions, applications. He or she must monitor workload on the system and reply to any messages. He or she can issue commands to various peripheral devices online or offline. Connecting to a mainframe computer. Typically at a customer site, mainframe servers are generally housed in a large area of building space. This is called the data center or the raised floor. People around the world connect to the mainframe computer remotely over a network from their workplace or home, using the keyboard and the dumb terminal, or PC running software that pretends to be a dumb terminal. One does not have to sit physically near a mainframe box to do one's work. Now, in the end, let us summarize what we have learned in this lecture. A computing platform is some sort of hardware architecture and software framework that allows software to run. The level of compatibility demonstrated by a cross-platform application is achieved by the programming language, also acting as the platform. The microprocessor and memory are contained as part of a large circuit board called the motherboard. The motherboard also acts as an intermediary between the microprocessor and other systems on the computer, such as drives and ports. A workstation is a computer designed for professional use by a single user. It usually has more capacity than a personal computer, but is not as high-powered as a mainframe computer that is designed to support very complex calculations and multiple users. A mid-range computer is a loosely defined term for a computer system that is more powerful than a general-purpose personal computer, but less powerful than a full-size mainframe computer.